Okay, this is section 4.1, quadratic functions and transformations. This is part 2, where we're going to go through and actually graph quadratic equations in vertex form. Okay, and we're going to start with this first problem where we have y equals x squared. Again, as we identified in the last part, this is the parent function, the easiest parabola that you're going to graph. Okay, and what we're going to do now is we're going to put in the ordered pairs 0, 1, and 2 to graph this guy. So if I plug in 0, 0 squared is 0. So I put my 0 there for y. If I plug in a 1, 1 squared is 1. And if I plug in a 2, 2 squared is 4. So now what I'm going to do now is I'm going to plot these ordered pairs. Now you'll notice the vertex of this graph, h and k are not there, so it's 0, 0. The axis of symmetry is the line x equals 0, so it's going to be the y-axis. Okay, so now when we go through and we graph this guy, I plot these ordered pairs, so I got 0, 0. I've got right 1, up 1, and I've got right 2 and up 4. Okay. And again, if you'll remember, our axis of symmetry is this line right here, which is the y-axis. So you'll count across how far it is from the y-axis. This point right here is 1 unit, so I got to go 1 unit to the left to graph it, just like we did with our absolute values. This over here is 2 units, so I'm going to go 2 units to the left. And now you have the curve of the parent function parabola. Okay, so that's a curve. Now, what you're going to do is you're going to use this parent function and you're going to shift on some of these. Okay, so like if we look at example number 2 now, okay, on example number 2, let's identify the shift. The shift says that we're going to move it down 5 units. Okay, so I'm going to go ahead and I'm going to plot the parent function. Okay, just like I did in the last equation here. Go through, we're going to plot the parent function. So we've got 0, 0. I've got 1, 1, and 2, 4. And reflect those guys across. So here's my parent function. And now what I'm going to do is I'm going to use this shift to say, you know what, I'm going to shift this thing down 5. Before I do that though, let's identify the vertex. The vertex in this guy is 0, negative 5. The axis of symmetry is the line x equals 0. Okay, so let's move this graph down. We said we're going to move this point, each point down 5 units. So I'm going to use my pencil here. Take this guy down 5 units. This is my new point. And let's make this guy a different color. So go down 5 units like so. Take this guy down 5 units. The guy on the left down 5 units. And then also take the last point down 5 units. And now your parabola is essentially the same graph, just shifted down 5 units. Okay? So you'll notice from one point to the next, you're going down 5 for each point. Okay? And now you have your graph of your parabola. Okay? All right, now let's take a look at these other examples here. They're going to get a little bit more complicated as we go. Okay, let's take a look at this third example now. On the third example here, first of all, let's identify the shift. We have a shift, in this case, is going to be right 4. The vertex is going to be the ordered pair 4, 0. The axis of symmetry is going to be the line x equals 4. So now we've moved our graph. Okay, So again, I'm going to go down, I'm going to graph the parent function. So I'll move this guy down. I'm going to put the parent function down first. Again, we've got 0, 0, 1, 1, 4, 2, reflect them, and there's the parent function. Now I'm going to take on this one here, and I'm going to move each point right 4 units. So I take this point, move it right 4, that right 4, right 4, this guy right 4, this guy right 4, which happens to be on that other point, and that's okay. And now I can draw my parabola. So with just one shift, the problems, if you can graph the parent function, the problems are not too horrible for you. Okay? All right, now, where we get into interesting problems is when we start dealing with the compressions and the stretches and the reflections and all those. Okay? Okay, so let's take a look here at y equals 1/2 x squared, and it's a little bit different because, again, now we have an a term that's not 1. So anytime we have an a term that is not 1, or we have a number in front of x squared, we want to identify the vertex first. And the vertex in this problem is the ordered pair 0, 0. And we're going to go ahead and we're going to plot that vertex. Okay? So I'm going to do a couple things here first. I'm going to put the parent function down. 1, 1, and right 2 up 4. Put the parent function down every time. That way I can see what my shift does. So I just put those points down. And we said the vertex of our graph is at 0, 0, so I'll put our vertex down right there. Okay? And so now we're going to have to plug in points. So I need to find the first 2 points to the right of 0. And in this case, it's the ordered, or not the ordered pair, it's the value of 1 and 2. So in my t-chart now, I'm going to plug in an x value of 1 and 2. And then what I'll do is I'll reflect that across our axis of symmetry. And in this case, our axis of symmetry is the line x equals 0. So this straight up and down line, which happens to be the y-axis in this case. So if I put 1 in, I've got 1/2 times the quantity 1 squared. Well, 1 squared is 1, so 1/2 times 1 is 1/2. So I've got the ordered pair 1 and 1/2. If I put 2 in, 1/2 times 2 squared is 1/2. 2 squared is 4. Half of 4 is 2. So now what I'm going to do is I'm going to go and I'm going to plot these 2 ordered pairs and then reflect them across the y-axis. So I go right 1 and I go up 1/2, which is about right in there. And I go right 2 and I go up 2. Okay. Now again, I'm going to reflect these across the y-axis. So we've got to reflect that point there, reflect this point here, and now you'll notice that our parabola has compressed a little bit. We've taken and we've squished it down. We've made it a little bit wider. So in this case, our shift on this one would be it compressed. There's no shift right or left. The vertex stayed the same in both, but we did compress it. Okay. All right, now let's go through some of these problems here where we have some multiple shifts. Okay. So as we look at this problem, again, we have an a value that's not 1, so I'm going to want to identify my vertex. And my vertex in this equation is the ordered pair -4 and -2. That's my vertex. Okay? And I'm going to go ahead and I'm going to plot that point first. Now, on these points, I'm not going to, on these 2 graphs, I'm not going to graph or plot down the parent function. Okay? So I'm going to go left 4, I'm going to go down 2, and I'm going to put a dot. That's my vertex. Now again, I'm selecting the first 2 points to the right of the vertex on the x-axis. So right here is my vertex. I want to select this point and this point, which happens to be -3 on the x-axis and negative 2. So these are the 2 points I'm going to put in for x, negative 3 and negative 2. So when I put them into the equation now, I've got the quantity 3 times negative 3 plus 4 minus squared minus 2. Well, negative 3 and positive 4 is 1, so I've got 3 times the quantity 1 squared minus 2. 1 squared is 1, so now I've got 3 times 1 minus 2. 3 times 1 is 3. Minus 2 is 1. So when I plug in negative 3, I get 1 out. If I plug in negative 2, 3 times the quantity negative 2 plus 4 squared minus 2. Negative 2 and 4 is 2. 2 squared is 4, so 3 times 4 minus 2. 3 times 4 is 12. Minus 2 is 10. So now these are my next 2 points. So I'm going to plot negative 3, 1. Left 3 and up 1 right here. And I'm going to go left 2 and I'm going to go up 10 right here. And then I'm going to reflect these guys across the axis of symmetry, which in this case, the axis of symmetry is this line right here of x equals negative 4. That's our axis of symmetry. Okay, so I'm going to put this point here. And now I have my parabola. It's not a V shape, it is a curve. I know I make it kind of sharp, but it is a rounded off curve. A couple of other things here that we need to make sure we have. The axis of symmetry is x equals negative 4. And as you look at that graph, you can tell that we shifted it left 4, down 2, and we stretched it out. So we made it thinner. Okay. All right, now let's take a look at this last problem here. Okay. On this last problem, again, we have an a value that is not 1. So again, we've got to identify the vertex. Vertex is negative 1 and 4. The axis of symmetry is x equals negative 1. So I'm going to go ahead, I'm going to plot my vertex. Left 1 and up 4. Okay, left 1 and up 4. And now the first 2 points again to the right of the vertex are the x values of 0 and 1. Okay, so if I plug in 0, negative 2 times 0 plus 1 squared plus 4. 0 and 1 is 1, so negative 2 times 1 squared plus 4. 1 squared is 1, so negative 2 times 1 plus 4, or negative 2 plus 4, which is 2. So I have the order pair 0, 2. And I'm going to also plug in 1. So 1 and 1 is 2. 2 squared is 4, so negative 2 times 4 plus 4. Negative 2 times 4 is negative 8, plus 4 is negative 4. Okay, so now I'm going to go plot those 2 ordered pairs in here. I've got the ordered pair 0, 2, so I go 0 and I go up 2. And I'm going to go right 1 and I'm going to go down 4. And again, the axis of symmetry is x equals negative 1, which is this blue line. So I've got the blue line there to help out. I flip this guy over, put a dot. Flip this guy over, put a dot. And you'll notice this one here is a little bit different, because this one here is facing in the downward direction. We flipped it. Okay, so when we talk about our movements on this problem here, our movements, we shifted the graph left 1, up 4, we stretched it, and we reflected it, which faces it downwards. Okay, one last thing here. I've got one last thing that I want you to do, and this is very important. There is one thing that I want you to ask me when you walk into class on Monday. I want to know, or I want you to come up and I want you to ask me, okay, this is going to be very important. I want you to ask me, how do you determine, I'll take that back. Let's do it this way. I want you to ask me where I grew up. In what town did I grow up? That's very important that you ask me that question when you walk into the room on Monday. Okay, this concludes section 4.1, graphing quadratics in vertex form.